Hi, my name is Tahina Ramananandro, and I'm a research engineer at Microsoft Research in Redmond, Washington State, USA, next to Seattle. I'm a member of the RISE team, but it's not the same as Marcos. The institution is that research in software engineering. It's a research team that has been there already at MSR for I think more than 30 years. And I have been there for the past 9 years almost. Well. And today I'm going to tell you about formally verified implementation of CBOR, CDDL, and a bit of COSE also. So what I'm going to tell you about in this presentation first is verified parser and serializer for CBOR, which I call ever CBOR, and I explain why I call it ever CBOR in a few. We wrote it and put it correct in the F-star proof assistant, and then we extract the code to C or Rust. And next to ever CBOR, we also implemented ever CDDL, which is a verified code generator for CDDL that we also wrote and put correct in F-star. And so the user just needs to write a CDDL data format description and then push a button. And then when they push a button, ever CDDL automatically generates C or Rust code for the data type, a parser from a CBOR object to values of that data type, and a serializer from values of that data type to a byte representation of the CBOR object. And ever CDDL has been enough for COSE and other protocols, and I'll show you during this presentation. We got the paper just accepted this month at SCNCCS that I'm going to present in Taiwan mid-October. And everparse and ever CBOR, ever CDDL are components of everparse, which is open source. You can have source code on GitHub. I heard before that meeting, what is this F-star thing? So it's a proof assistant, proof-oriented functional programming language with dependent types, refinement types, and others. Features that is meant for verified low-level programming. So there is a subset of F-star that we write our code in, and that can extract to C, Rust, or WASM. But we can do our proofs using the full power, expressivity power of F-star, and those proofs are backed by automatic verification with Z3. So F-star and Z3 are developed at MSR RISE. Nick Swamy is the main author, F-star, and Nikolai Björner is the main author of it. In practice, we have also introduced separation logic framework into F-star to reason about resources. I won't get you more into any such detail about how to reason with separation logic about the model of a C program, but it's just to tell you that that also expressed new, and we presented it last month at PLDI. So F-star is actually the cornerstone of a much larger project that is called Project Everest, that has been interested in proving the correctness of components of the HTTPS ecosystem, starting with the TLS 1.3 protocol. And so when it started in 2016, that was its goal. And then along the years, many sub-projects within Everest have emerged and have become projects of their own. One of those has been Evercrypt or Hacklestar, which is a formally verified library of cryptographic primitives and cryptographic algorithms that has been deployed into the Linux kernel, Firefox, Python. So this has been one project also written and proven correct in F-star. Another one being everparse, as I'm telling you, is this. It's a framework for verified parsing and serialization. And an application of everparse has been deployed into Windows and Azure. And I'll be giving a broader talk about everparse on Thursday at the Usable Formal Methods research group meeting. So even though Everest itself has officially stopped, each project that came out of it is still alive and well and active development, including everparse, and then ever CBOR and ever CDDL are themselves new components of everparse. Right. So what do we prove for every CBOR, we prove at the level of the specification that serialization parses back to the same CBOR objects as the one that you were serializing to. And we proved that the deterministic encoding, I mean, so-called deterministic encoding in section 421 of the CBOR RFC is indeed deterministic, and that it yields a unique binary representation, which means that it's non-malleable and it can be used in such context as hash-based authentication. On the implementation side, we prove that our CBOR parsing library is memory safe and absence of panics or integer overflows or underflows, and that it is functionally correct with respect to the specification. Yes.
What specification?
The model of CBOR, of the CBOR generic data model, and the deterministic encoding and the data format. Yes.
So you read 8949, built a model from that.
Yes.
And then now you can prove that your implementation is consistent with that model.
Exactly.
But you cannot prove that you read 8949 by
exactly. So voilà, that's the only gap missing at this. I mean, on the trust there. I mean, along with of course the trusted computing base that is the implementation of F star and the extraction to C or worse. Yes, interoperability is a way to solve this issue. On the implementation side, right now we are right now what we have is implementation of the deterministic encoding without support for floating point at this point. I have seen some discussions on the mailing list, which I may use as a pretext. I mean, to not have pursued much more implementation into support for floating point numbers for the deterministic encoding, but I pledge to propose something at some point in the next few weeks when I add the support for those floating points, because later in the pipeline I have some CDDL formats that require some floating point values such as time and so on. So yes,
something weird happened in the last meeting I was in, CBOR, the one before that, where people suddenly allowed floating point values in a time. I have that on my list of things I want to clarify after the meeting, but that's probably the one point where floating point comes in. Protocols that we are working on the IETF, and people want better resolution of times than just seconds. They don't get a better resolution than a microsecond, but that is for most applications.
Thank you. Alors, one important thing is that our implementation performs no heap allocation, and in the sense that the parser is not going to do a deep parsing of the whole object at once, but instead the API provides the constructor and destructor functions that can allow the user to peel each layer one by one as they wish, especially for arrays and maps. We provide an iterator and a get function for maps. And on the construction side, the constructor function for maps takes a mutable map entry array and reorders the elements of reorder the entries of the map in that array with respect to the deterministic encoding before serialization. And so we do that without serializing the objects that we want to take to make a map from. So we mean that the allocation of such objects is really on the responsibility of the application, in such a way that the application can construct this object in a random order or in any order, as opposed to encoding everything in the right order from the get-go. So we leave that flexibility to the application, so that then the application can serialize the object once it's done. And so well, to do that, we sort the entries of the map at the level of objects instead of bytes, and because yes, it is nice that the 8949 has changed the deterministic ordering in such a way that this has become possible. Thank you. Thank you. So we provide the validator, which for the deterministic encoding validates bytes in constant stack space. We believe that we can extend the validation in constant stack space for definite validation of CBOR objects outside of the deterministic encoding as soon as there are no maps in map keys, which is the case, for instance, for COSE, which requires map keys to be only integers or strings at most, but at least no maps in there. But in general, we believe that checking the absence of duplicates duplicate keys in maps, in general, would consume an unbounded amount of stack in the worst case. That is, there may be an attack where an attacker could send deeply nested maps where a map key contains a map that itself contains a map key that contains a map, and so on, which may blow up the stack of validator that will check for the validity of such a map, of such an object. But once the bytes are validated, we provide, well, as I said before, a parser that is not going to do deep parsing, but it will provide iterators for arrays and maps and the get function to extract a value from a map given a key. And for the serializer, since, as I said, that the CBOR object to be serialized is allocated on the responsibility of the application, the stack consumption then is linear in the nesting level of that object, in the sense that our attack model is that the application controls its own allocation, and our attack model consider only bytes coming from the outside as a potential threat against which we need to defend. Bytes that come from the outside and are deeply nested, then we have to guard against the stack consumption when validating and parsing that part, parsing and serializing that part. As the objects, as the map constructed by the map constructor function already has its entries sorted at the time of construction, we no longer need to do any more sorting when we serialize it, because the order is already maintained. Do you have any questions on ever CBOR? I'm going to present the performance a little bit afterwards, because I'm going to present the performance at the same time as ever CDDL. But otherwise, do you have any questions on ever CBOR? Thank you. Then, yes?
Do you use any test vectors or
yes.
test template? Are you going to get to that?
Yes, I have used these old test cases among the 82 test cases from the CBOR repository, the CBOR test case repository. There are 29 that are meant for deterministic encoding, and I pass along. And there is also beyond that, I also managed to interoperate with PyCOSE for the COSE implementation that I derived from CDDL, but that's.
Yeah, those test vectors were written in 2013.
Yes.
And we have neglected updating that, but maybe we have good reason to do that again now. First of all, we have all this stuff in the CDE document that we could add to the test vectors.
Yes, please.
Yeah, we probably also have some real world test vectors we could add. So that might be a work item.
Which vectors are those?
Well, for example, we have to validate core, we have a huge number of CBOR.
Are they intended to check what is deterministic encoding?
Not necessarily.
Yeah.
Okay, yes. So once we widen to the full CBOR, I mean full definite length CBOR, then yes, we take. I don't remember the URLs on that.
Are they in GitHub or?
Yes.
It's in the old CBOR repository, not the CBOR WG repository, but under github.com/CBOR, and you can find it there.
Yes.
There's a huge number of tests in QCBOR.
Yeah, that is, I think, what is going with. So because Lawrence also has good examples.
How many of them are meant for deterministic encoding?
I mean, I don't know why you guys are fixated on that, but because I don't think that's that hard. But I mean, there are lots of hostile input for all the different APIs, right? To trigger error conditions and the APIs and stuff like that, right? And they're not particularly, some of them are organized, but not all of them. I mean, I'm basically looking at the code line coverage of my code and diddling the thing, adding test cases to get the code coverage up.
In that regard, the co-run structure pro same. Just more messages, but I think far.
Thank you. I will integrate with test cases once I switch to implementing the definite length. Thank you.
Would it make sense to gather these test vectors? Like
Very much so.
Yeah.
Yes, that's.
I was trying to say, this is the work item for the meeting before the next IETF.
Yeah, and we have the same issue with the COSE examples, which are still residing in the same place.
So I think the important thing is to make sure that we don't gather them once, lose the connection to the source, but we actually find a way to integrate them from wherever they are actually maintained.
Yeah,
Okay.
but you're not saying subgit, right?
The number of deterministic test cases does not have to be proportional to the number of messages on the mailing list.
Yeah.
And then on top of CBOR, we have developed a CDDL, which we mean the users to use as a push button code generator, where they write a CDDL data format description, or they extract it from an RFC, which I hope we can. Well, I mean, one of the goals of this meeting is to assess how much we can extract CDDL from RFCs for automatic processing. And then the users push the button, and CDDL generates parsers and serializers that are memory safe, arithmetically safe, functionally correct, non-ambiguous, and when used with the deterministic encoding, then they are non-malleable. And we've been doing so, the users need to do zero proof efforts, in the sense that when they push the button, we generate proof, we generate a code that is correct by construction. And what are the formal guarantees? So yes, no ambiguity, the serialization passes back to the same value. The CBOR object obtained from the CBOR object obtained by a serialization of a value is unique with respect to a CDDL specification. And then once coupled with the CBOR deterministic encoding, we obtain non-malleability at the level of bytes. And again, the generated code is memory safe, absence of panics, no integer flows, and functionally correct. So we generate from given a CDDL data format description, we generate a program data type in C or Rust, and then we generate a validator, which I forgot to write in the. I forgot to write in this slide that we also generate a validator from CBOR objects that tells whether the CBOR object is valid with respect to the CDDL data description. And then we generate a parser that takes a valid CBOR object and produces a value of that program data type that we generate. And then we generate a serializer that takes a value of that program data type and generates the byte of the deterministic encoding of that CBOR object that is valid with respect to the data format and passes back to the value. And the CDDL is enough for most COSE data structures from the reference standard. And more data format descriptions that I'm going to tell you about a bit later in this presentation during the hackathon.
Now, if you say most, we of course get very, very curious.
Yes. In 2 slides, I will tell you one that we do not support, and but bear with me. Thank you. Yes. Yes, so given the CDDL description, we generate a validator that checks for validity. We generate a parser. The parser extracts CBOR object into the values of, say, the scalar field of the map, for instance, or of an array. We generate iterator for arrays and the tables. And again, meaning that we do not heap allocate because we are not doing deep parsing all the way down. And so the iterators are feeding each layer one by one. Given then for serialization, yes, well, the serializer that we generate is defensive in the sense that it takes a value of the generated data type, regardless of whether it satisfies the serializability constraints. For instance, if you have a CDDL map group that says, for instance, one cut BSTR, followed by star int arrow any, the type that we generate is a record type of two fields. One field for field one that is associated to a byte string, and another field for an iterator for a table of CBOR objects. And that table, if the application creates an element that has key 1 in that table, the serializer will detect it and reject the object and say, no, you cannot serialize that object. It will, so I mean that it will gracefully fail in that case. So voilà, the serializability condition about avoiding such duplicates at serialization at runtime. I'm sorry. Avoiding two large arrays or maps. They are larger than 2 to the 64 number of elements. Integer range, string size, and so on. And the output buffer must be, of course, it must be large enough to contain the deterministic encoding. Voilà, so this, the serializer will detect if any of those does not hold, and it will gracefully fail. And so it means that the serializer is secure and is not going to silently produce data that is not going to be valid with respect to the CDDL, or is not going to parse back to the same value or anything. Voilà. During that serialization, we do not perform any additional heap allocation. And again, the stack usage is linear in the size of the specification rather than the input. And we may be less efficient in terms of how we write the size fields of arrays and maps, in the sense that we first write the array and map entries without trying to determine the size of the array, in particular because if the application provides an iterator and the size is not known, then we cannot know in advance the size. And so when the application is done writing an array, we shift to write the size. So it's probably inefficient, but at least it avoids any heap allocation or anything. And then to maintain the, that's what we discussed with Lawrence at the hackathon, is that when we serialize the deterministic encoding for a map, we establish and we maintain the order by doing insertion of each element at a time, one at a time. And this insertion both maintains the order and automatically detects duplicates, which allows for the serializer to gracefully fail if, for instance, there are duplicates in a table provided by the application. We have synthetic benchmark for CBOR and CDDL where we, yes, for the first case, we are parsing and serializing a record of 9 fields. And we are pretty much, for validation and parsing, we are a bit faster than tiny CBOR from Intel, but we are still significantly slower than QCBOR, but I believe that we can improve on the speed by doing more specialized serialization. Because right now, for instance, we have a generic function, a serialization function that we inspect the type, and as opposed to trying to serialize an integer, I mean, doing special cases to serialize integers and so on. For map access, it's accessing an element of a map by its key. So that is, we insert 10 entries in a map, and then we look up. And so here we measure the lookup time. And here we are leveraging the fact that we are encoding using the deterministic encoding, and so we can stop if the key is larger than the is the key is smaller than the key of an element that is scanned into the map. I have a question to Lawrence there. When has do you have an optimized map lookup for the deterministic encoding that stops if that stops if it encounters an object that is smaller than the key.
So there's a lookup by map key.
Yes.
Yeah.
And yes, the lookup function accepts any type of map key. And then for arrays, I have to remember, but I think it's yes, deeply nested arrays. Yes. And the parsing in universal CDDL is a bit slower because we are scanning the element of the array. I think we are doing a quadratic number of scans when doing a jump to the next element of the array of the enclosing array. That is, we have a benchmark where we produce deeply nested array and deeply nested arrays, and we try to jump to the second element, and to do that, then we need to jump to each layer in the nested array on the left-hand side. And that's where I believe we are a bit slower.
Yeah, when you don't allocate, it's hard to do the nested structure less than quadratic complexity. There is a second after the ARR, right?
Yes, that's the second there.
Okay.
That's the use.
So the other implementations also take seconds to
Yes.
do it.
So rank and map are microseconds. Array is yes.
So how many array?
10,000.
10,000. So the second through 10,000 is
Deeply nested array, yes. That's
100 microseconds per element, something like this order, which is not that fast.
and then for COSE, we interoperate with COSE. We should use the test cases from COSE. Thank you, Hank, for pointing them to us. And here we are just saying that the parsing and serialization are still negligible compared to the crypto involved in the signing verification. What did we do during the hackathon? So, alas, I was hoping that we could do more performance benchmarking, but we instead focused on applicability of CDDL by digging through CDDL specifications and looking at what CDDL produces. And so we support most of COSE, CBOR Web Tokens, EIT, and some drafts so that some of you pointed us to, and thank you again for that. And that's exactly what I was expecting from the hackathon on this side. On those specifications, I had to do some syntactic minor rewrites to account for the syntactic transformation that we currently do not support, but we plan to support them in the short term. Unwrapping, generics for CBOR and so on, occurrence bounds and floating points. And then is the elephant in the room coming, as you were asking a few slides ago. What do we not support? Recursion. I claim to have a good reason not to support recursive CDDL descriptions because for validation, you may blow up the stack. For COSE recipients, I might be wrong because the recipients are at the end of an array, and the array is the last element of the COSE recipient. So the same trick as the one that we use for validation of CBOR objects may apply here. Where actually, so you have a counter, you start with 1 and 1 object, and then you enter the object, you decrease your counter, you read the header tells you how many children you expect, you add that number of children to your counter, and then you loop. And so until you reach 0 or invalid, and you are guaranteed to terminate because the header is at most, at least 1 byte. So you are guaranteed to advance in the input buffer. And so I hope I can try to apply that to CDDL descriptions of a similar shape, but well, we need to generalize that to beyond the policy recipients.
One question.
Yes.
And the drafts you evaluated, you also include the DNS CBOR draft, the DNS CBOR draft, or because you just you don't there.
I don't think I included the DNS CBOR, but I have a list. I have a list that I mean the dots are in progress for those that I have not included on the site, but that have been that I mean that I got from the.
Yeah, just to say I would be interested in the results first because the CDDL is quite complex.
Yes.
And because it's so complex, I'm also interested in scenario debugs. So in the CDDL itself.
So which one do you?
Draft lenders DNS, CBOR DNS.
Alors, I need to type or
I sent it to you via.
yes, please. My email is this one.
You also have RFC 9393 that has a full CDDL.
I've lost room audio.
You get more CDDL.
I believe I saw that, but I'm not sure I went. I reached that, but I believe I saw it. Thank you.
Sure.
Well, so this is my email address. But I'm not done. I just interrupted just for you to take my email address to send me any more references and suggestions. Thank you. Yes.
May I ask a question?
Yes.
On the topic of finding bugs in specifications, you mentioned that you've run through a few of those drafts. I would expect that all of those drafts really had unambiguously parsable CDDL. But CDDL is quite open to allowing you to write an expression that like you can validate, but you can't assign fields to. So I was wondering, given that ever CDDL turns this into possibly Rust types, can ever CDDL tell me whether such an assignment is possible unambiguously?
Yes, that's the point of ever CDDL, that we reject the CDDL specification that is ambiguous. That cannot be where the serializer could not serialize unambiguously. Yes, there are. So this is the major part of my answer to your question. The minor part is that if you have an alternation, the serializability condition will say that if you want to, so A or B, the serializability condition will say that if you serialize some object for B, it should not be caught by A. And then instead of ever CDDL rejecting the specification, the serializer will reject the object at serialization time. So it is a fail-safe approach that allows more specifications to be used, but at the level of the application, fewer objects can be serialized, but at least the serializer will tell the application that they should stop.
Yeah,
but that is a runtime error and not something that I get at generation time, right?
Yes.
I think it will be generally hard to prove that no B can ever be an A.
Yes.
I mean, for grammars in general, you can prove that.
Yes. But in CDDL,
there might be tricks you still can apply.
Yes, yes. I have a partial disjointness checker within CDDL, ever CDDL that will detect when two sides of an alternation are disjoint. It is partial in the sense that right now it does not cover maps, but I believe that I should be able to extend it somehow. But at least I have something that I have such a disjointness checker that can detect such possible ambiguities in a CDDL specification. Yes.
That would be a really useful tool to have.
Yes.
It's way too easy to make mistakes of this kind, and finding them automatically, or at least most of them automatically.
Yes. In fact, I think I need to correct myself a little bit. Is that right now I will reject a CDDL specification when there is an array alternation where the two sides are not disjoint. It's not true for maps. of course, because of the extensibility mechanism. I will show you a bit later in this presentation. But I have thought, okay, you are telling Christian and Carsten, you are suggesting that this would be a better approach from the user point of view to reject the specifications at compile time rather than to allow the space to
Yes.
These do both, but
okay,
definitely have to have a tool which you can apply to a grammar and it finds bugs. So the other bug we found in 1952, that is also something that should be checked for.
Okay.
It's also a situation where the grammar actually can generate an instance which then doesn't pass.
Yes.
So I sent you some information on how to submit the data.
Yes, thank you. I have not yet because I wanted to confirm that actually. How much time are we into? Because I'm completely lost in the. I don't have.
I have to leave in 10 minutes, which will not stop you. I think you have 30 or 40 minutes left.
Okay, thank you.
So that is more than enough time. If you want to file it around, which obviously is a good idea. We can do this together. You will be the official filer.
Yes.
We can be your cheerleading over the review, right?
Yes,
So
yes.
you don't have to do this alone.
Thank you.
Very important.
Okay, then in that case, since you are here, okay, and if you don't mind, I'm going to jump into the presentation, and then I will go back because where is it? Well, so here are, I believe, the inaccuracies I have found. Yes, just to well, the page interpretation of COSE 6 structure. Maybe I should show COSE 6. In fact, what's happening here? Why do I?
Yeah, I sent you a mail with the wrong section and the right section. So
Yes, yes, and just I just want to project it. Yes, I don't see structure. This C structure. Can you see C structure on the screen?
Yes.
Yeah. Thank you. So, oh yeah, sorry, I have sent for that. Sorry about that. Sorry. It is here. Voilà. It's in the wrong order. Okay. Sorry about that. C structure. No, it was the right order. Yes. Voilà. So this is the C structure where so there is this sign protected field that appears as optional. So that the C structure can contain 4 or 5 elements. But since the CDDL semantics has to be understood as a peg with a greedy interpretation of occurrence operators, as soon as sign protected matches, if there are only 4 elements, then payload will be missing and it will reject. And the CDDL will, sorry, the validator will reject.
So the interesting thing is that an implementation that applies this to instances is unlikely to find this.
Yes.
Because the NPR serialized map is not going to match an external AAD in general.
Yes.
But if you actually do the deployment test,
exactly.
then you can find it.
Yes, and that's actually what I found is that the FRCDL is rejecting that specification because it cannot prove that the sign protected and external AAD are disjoint.
But even if
even
if this had to be parsed, unlike a peg parser for say a string, a peg style parser for CBOR items does have advanced information, not about the properties of the later elements, but it does know the length ahead of time, especially in a context like COSE, where deterministic encoding is required. So there is no ambiguity. There should not be an ambiguity here for the parser if it can rely on the length of the array to be encoded already at the start of the array.
There, I think I have 2 answers there. One is that consistent with the fact that CDDL could be.
There is no ambiguity. Christian is right that there is no ambiguity.
Yes.
The problem is that the ambiguity resolver that is built into PEG, which is prioritized choice or greedy, as you can call it, it's going to match the wrong things. So it's going to consume the external AAD if that happens to match an empty or serialized map. in this example. And then suddenly you don't have enough input left.
Yes.
You will fail the whole.
So
And the second part, yes, yes.
this
Yes,
is
go ahead.
something that implementers of Kira have also faced. But it's I think it's a matter of how PEG is how the concept of PEG is mapped onto CBOR. Because that piece of information, how long that thing is, can just as well be emitted into a PEG machine. Which just means that the CDDL needs a bit of pre-processing in order to get that field available, and then all of this becomes a choice rather than an optional field. But that's a matter of how CDDL and CBOR is mapped onto the concepts of PEG, and not a fundamental limitation of that the CDDL is PEG incompatible.
Well, but then the second part of my answer, which may actually yes,
I share your slides and
Stop sharing and pass it.
so you want to share something? Sorry, go ahead.
Yeah.
Sorry about it.
takes me a minute to.
Because I had the second part of my answer, which is that if you add irrelevant star int, for instance, at the end of your array, then you lose the information on the side of the array.
Okay, so the one at the top is the one that is in the RFC,
Yes, I had.
and there is like a canonical transformation which you can apply here to make this spec possible.
Yes, I had a slide actually that shows that.
Okay.
Sorry about that. But thank you for jumping.
So the first one might be might gobble something early. The PEG parser doesn't look at the start whether the array has 4 or 5 elements. It just starts working through the group, and the group matches the signature. I mean, you never do the actual matching because that structure never goes on the wire, so you will never encounter that bug. But if somewhere in your implementation you check what you are producing, you might run into it. And then the second one goes into the body protected, and the third one, if it is present, everything is fine.
Right.
If it is not present, then external AAD is checked whether it actually is sign protected or an external AAD, and the sign protected is a somewhat restricted. I didn't copy the language and just realized that. Sorry. The sign protected is somewhat restricted, but you might by chance hit it. For instance, sign protected allows 0 length byte string, and
yes.
maybe your external AAD is a 0 length
Yes.
byte string, and then that is consumed, and you still need 2 elements, but you only have 1. And the group choice in the second example works around.
Yes. Yes, well, I had a slide which to illustrate that exactly that. Thank you. No problem. And the other, I believe, inaccuracy in standards that I found, and actually I made many places. Let me share again. Is this extension mechanism of map groups? Where is it? Maybe here. Share. Okay. Share. Enter screen. Where is the? Okay, so I have 30 minutes. This the sharing. Sorry, the extension mechanism where you have optional map entries without a cut, followed by a table. So in COSE, for instance, if you provide a header map that has entry 4 associated with an integer, then this header map will validate that CBOR object. And is that implemented in COSE?
No, when you have a key 1, this is always going to be an algorithm identifier, so you're not allowed to put it somewhere else. So yeah, exactly. So the problem is not if you have a key 1 and a value 1, or a key 1 and a text string, But if you have a T1 and a floating point base,
Yes.
something like that,
Voilà.
that is going, with a cut, it's going to cause an error right at the first line of the group.
Yes.
And without a cut, it actually falls through to the label values case, and it gets accepted
Right.
here as an extension. I mean, the next step will say, I don't know that it's this extension, but for now, this is not as selected.
Alors, the problem is that this pattern, I have encountered it several times. For instance, in ad-hoc information, in that draft, where is it? It's the same thing. It's the same pattern in ad-hoc information, in other non-IETF standards, such as trusted computing group DPE for DICE protection environment and so on. Here it seems that we believe that this pattern without the cut is not intended, and the cut could be inserted instead. Alors, I have implemented both in CDDL. In particular, I have implemented the version without cuts in the past 2 weeks, compared to what we submitted for the paper, where we had to replace those with cuts.
So what we just didn't see is that Jeremy has to go, and thank you for this interesting discussion.
Thank you. Sorry about that. And then I have a third proposal for COSE that actually, where the COSE specific standard claims that it is not possible to express the fact that, I mean, okay, assuming that we turn those arrows into cuts, that it is not possible to for read 5 and 6 to appear both together. And I believe that I have a way to express that in CDDL. And I'm going to show you how. Alors, here I need to jump to the repository because I don't know, I have it here. Alors, celle-ci, COSE. I think it is this. Voilà. Okay, so if I have a symbol for a type that will always reject, alors here I call it error part no match, but I believe MC range can do. I believe 2.1, something like that. Then 5 arrow BSTR and 6 error part no match with a cut, or 6 arrow BSTR and 5 colon error part no match with a cut. Because I also need to ensure that none of those appear. 5 or 6 may both be absent, and that's why I have this question mark here.
So this is the cut fail pattern.
Yes.
That everybody who's ever done anything with forward is familiar with.
Okay.
It's maybe a lot of ceremony to get a relatively simple result. So at some point we may want to think about a way to get this expressed in a simpler way. But yeah, that would work.
So do you believe that I should also submit a proposal to enhance the description of the CDDL there, or is it too much?
It probably makes sense to work on such a proposal. I'm not sure it would come to standard next week.
Well,
But the CBOR working group certainly has CDDL, work on CDDL schedule.
Okay.
So such a proposal might go in there.
Okay.
And of course, what I would like to do here, and maybe put with generics or something, is get some of the verbiage out there, because that's right now a bit too much you need to read and actually to sort in your mind before you actually understand what's coming next.
Thank you. So that's pretty much about the inaccuracies I found in the specific. Yes.
Is there a reason why you're not putting cuts into?
No, it has not. Those two are independent. I mean that if I put cuts, then it will work even better. But no, it was just the fact that I wanted to express that constraint that was not there.
Yeah.
But, so those two are independent.
So we don't have something that would have this fading semantics.
Alors, in fact, you do. I mean, CDDL does, because an empty range, I think,
Empty?
range, integer range, yes, 2.1 or something. So yes, I don't think I mean
It doesn't work without a cut.
yes, it doesn't work without the cut. Exactly. Yes, thank you. And that's pretty much all for the inaccuracies.
But that's not an inaccuracy. That's a limit in the selectivity we can have So there is a limit to the expressiveness of any grammar. Formal notation has a limit to expressiveness.
No, I'm saying that it works. But it just COSE did not dare to write that, and that's why I wanted to propose that as an error.
So let me just try to explain this historically. Cuts have been part of CDL from the beginning. So you would have asked me when exactly we put them in, but we put them in pretty early. The problem is the number of IETFers who have spent part of their life programming in Colon is limited. So it would have been very hard to get other people to actually understand what this is doing. So we put in the functionalities there to be used, but most people don't understand it. And now maybe it is a time to start a little campaign to actually use that functionality. And then we undoubtedly will find cases where it doesn't work as well as we would like it to. So any approach to actually exploit this mechanism in earnest will probably have to look at these cases that don't work as well.
Yes.
So it's not something that I think will need to result within a year or so, but will be part of the further evolution of CDDL.
I don't know.
So yes, one of the things, sig structure is never decoded.
No.
All you do is create it and hash it.
So that's why I get care when I saw this stuff from Jim and said, well, we're never going to validate it. But that's of course only true if your implementation is structured that way. If your implementation is one part that generates it and the second part that checks it and the third one that serializes it and the hashes it, then you're still running into the problem. So it would be okay to fix.
Yes, but it is less important. I agree that it is less important, also because the CDDL in COSE is not normative officially. But I just wanted to polish that CDDL for automatic processing. That is, if I want to extract the CDDL from the RFCs and then put them into a CDDL to process the code. I am not sure it would be worth having a mode in CDDL that would only produce a serializer without a parser. But that would be a case where I should. Okay, and then okay, so we were we are here. Yes, COSE recipients. But then yes, now my question about not supporting recipients CDDL description for CW. Sorry, for EAT, for nested claim sets in nested tokens. Is there any expert on RFC 9711 here?
Well, of course,
what should happen if there are, an attacker produces a deeply nested token? What should happen at validation time to avoid stack exhaustion? Or how deep is typically the nested claim set?
Probably not that deep, but it's kind of device dependent, right? It's like architecture dependent. If you're trying to construct an 8 token that's like the data station of a Airbus A380, with all the you probably could nest up, maybe hundreds, right?
Yes. So the depth of the thing.
Yeah, the depth.
It's yes.
No, yeah.
You probably wouldn't see objects at this point because the tree will like this otherwise.
Yeah, maybe not even.
I believe that an A380 will not try to validate such a claim set about itself.
It's like, okay, you got the top level, and then you sort of sub-assemblies, then I don't know, the cockpit, and then this avionics, and then this submodule, and this aviation module, right? And each of those could have like 10 nesting. So that's the best I could think of. But
okay, then
but the assumption is that anybody validating that stuff is going to have, they're going to make decisions about that. And E is more of a framework than specific annotation format. So when some cases you're not going to have any nesting at all. In other cases, you might just have a couple levels and stuff. So, I mean, in your world, oh, well, here, yeah, I mean, yeah, you have to just, I mean, some people are going to deal with that nesting by trying to run on the stack, and some are not, right? Some are not going to deal with that on the stack. So, and some of that nesting is going to be distributed across various verifiers too, because there's different kinds of nesting. So, I mean, you may, I mean, in the A380 case, you would probably have, 5, 10 different verifiers that are interconnected. So no one would have to validate the whole stack.
Ah, okay, I see. Yes. So you mean that from the security point of view, is it a realistic attack surface? Do you think of an attacker trying to craft any of those nested?
Sure. I mean, I don't know, this day and age, everything's an attack surface, right? Not about the probability of them doing it. It's, you got to assume they will try to attack. So, I mean, if you're trying to produce a commercial quality, EAT verifier.
Yes.
I mean, I would also expect. I mean, maybe that's happening in Rust, but I would also expect that those are backend machines, so they have lots of memory and right there. The verification is happening in the server side. Servers.
Attestation results are also including EAT. And therefore, which
I mean, it could be, yeah, right, yeah. I mean, I think the way I would, and I have not done the implementation of the nesting, and I mean, the way I would probably do it, if there would have to be some hard limit, to be safe. There would have to be some hard limit in the implementation to be safe, right?
Yes.
So I limit the depth.
Yeah, just like it's 10 or something, right? Or it's a point where somebody has some control, where you have to talk up to an allocator to try to send, and then they decide, well, you try to allocate to another memory, and you talk with the allocator, and the allocators, for the next level of descending, they're like, no, you can't go beyond 10 or something.
So the CDDL validator that I wrote has a stack size limit of 10,000 by default. And I can tell you, I had to up that number for the occasional tests.
Right.
There is probably some out there.
This is okay.
Yeah, 10,000 recursion levels. Wow.
Yeah, that's the non-takeaways that you have in the structure of the program.
Yes.
It's going to be very simple images that are going on. This is much finer granularity than what you have in your
Yes.
approach.
Nested tokens is, maps to hardware, more or less, right? For the most part. So they have another level of nesting. You have to have some more hardware in the attestation world, right? So it's going to be another CPU and some memory. So that's a lot more expensive than.
And even for attestation results, then to map directly, because there you're representing structure.
And yeah.
Good, we have a little more than 10 minutes left.
Alors, what do I have left? Ah, ben voilà, it's the end of my talk, actually. I believe that the implementation, I am ending up with for CBOR WG CDDL with respect to initial performance measurements and memory consumption is already reasonable in many cases, many if not most. As soon as I get interoperability, which I have, for instance, already for COSE and by COSE. But the main thing is that I get strong formal guarantees in such a way that I claim that it should no longer be needed to handwrite parcel serializers for formats defined with CDDL descriptions. I wonder actually which CDDL such parcel serializer generator unverified ones are used in practice. Are there? I mean, there are, yes.
CDDL to C1.
I mean, a CDDL program. Sorry, a program that takes a CDDL, data from a description, and generates a parser and a serializer without a proof.
There are 4 implementations that I'm aware of. I forget how that thing is named. It's from one of the leading chip manufacturers.
No,
ZCBOR.
Yeah.
ZCBOR.
ZCBOR, okay.
Yeah, so that takes the CDDL and can generate parsers that actually parse the CBOR based on the CDDL. I think that is the only such implementation out there in the open source world. The other 3 implementations are just parsers, CDDL parsers that then can validate the CBOR instance against the parsed CDDL.
Yes.
And one is the original CDDL tool, one is the Rust CDDL tool, and also the JavaScript CDDL tool that I haven't played with at all yet. The author of that thing is called Christian Roman. Is sometimes in
You know the duplicate keys in Bash.
So it's not an executive, so no problem. Yeah, so I think that is the current state.
Thank you. Then I have a look at them, and also especially about their support for secure serializers. Maybe I should open the forum for questions at this point. If yes, do you have any further questions?
What is the difference for the or what is the reason for the understanding between the different? So you mentioned there is some kind of difference for.
I would say the main difference is about QCBOR and Tiny CBOR encoding. Sorry, the application encoding the CBOR object with QCBOR in the order in which it will be serialized. I have a question actually to Lawrence at this point. For a map, if a user uses QCBOR to serialize the entries of a map in any order, can QCBOR for them?
The 2.0 version can, the 1.x can.
Okay, and that the two version appeared in April or February?
No, it's been, I think it's longer than that, and it's not you know, it's still an alpha.
Okay,
state.
I see.
Yeah.
Okay, because we were comparing with QCBOR 1. Sorry, with QCBOR 1, precisely because we did not see QCBOR 2 appeared back then. And then in that case, yes, the fact that one could not sort map entries with QCBOR 1 meant that the application had to serialize things in order. And since we are allowing the application to serialize things in a random order, the application allocates in a separate subject and then we serialize. That's additional step, I would say, is the main reason for the difference in performance. Another being also the fact that we are enforcing the deterministic coding, whereas Tiny CBOR does not, and QCBOR 1 does not.
It's not like because there's performance optimization.
Yeah, they probably is.
Yes, there might be, yes. At least I know that we have room for improvement also on our side. As I said before, by doing more specialized serialization at times. So, for instance, if we know the size of an integer in advance, then we should take advantage of that, and so this kind of thing.
When you're dealing with when you're you're writing on the commercial quality implementation of a whole protocol, then there's lots of other considerations come into play, and right, and the power of the API and what the APIs can do and stuff like that. Like, I mean, I've done a COSE implementation, and it's a fairly complicated thing to do, and I mean, I would suspect that my implementation is going to be a lot tighter than what you guys are generating, because I mean, I'm thinking about a lot of things in a different way, and I'm doing object orientation, factoring of the implementation in an optimal way and stuff like that. So, I mean, I mostly optimized CBOR for code size.
Yes, that's also something we did not look at code size optimization at all. Right?
And that's what I look at. Like, that's where I really spend my time with is code size. And that also, in some cases, that gets you speed. Some cases.
I think that's also something that you should consider for the embedded use case. Because, for example, we have in Riot CBOR parser and serializer that is also written from code size, so it might be that this is even slower than that.
Do you think you could integrate it into protocol analysis tools? So you put in a specification of protocol to analyze it, it can generate protocol implementation for you.
We have not tried that yet, but if which tools do you have in mind?
I think Crypto has something similar.
Could you speak a bit just to Mike for that remote users that you have?
Yeah, just asking about whether we could integrate it into protocol analysis tools so they can automatically generate verified implementation.
At the level of the protocol, you mean?
Yeah.
We have not tried that because I mean at this point we were focused on the data format at this point. But we are aware of work by Brian Parlow at CNU also trying to do that, to generate fully verified protocol implementations from specifications. Brian Parlow at CNU, yes. I don't remember the name of the project, but yes.
I think that would also tie in well. Sorry, I'm getting terrible echo. I'll speak for a moment. I'll take my headphones off. I think that ties in well with something that we're working on with Crispin around formal verification of tools that use CBOR. I think that your tool, that the F-star descriptions that you're building, can be quite helpful also in verifying code that is in verifying formal descriptions that are generated from Rust code. To tie existing and possibly optimized for size implementations back to your formal work.
Yes, that may be a different approach that, in the sense that we could, yes, you mean that we can prune the implementation out of our CDDL and just generate the specification, and then
yes,
hacks can do the rest or something. Yes, yes, we can consider also that other approach in cases where more manual proof by the user is acceptable.
Yeah, that would not even be manual proof. That would just be like the user asserting that, for example, some processing function processes precisely the the CBOR that is equivalent to your model.
I would be interested in seeing whether those asserts succeed in practice at the level of your code. I would be interested in seeing that. That's where I believe that some manual proof may be needed for these asserts to succeed.
Let's try that.
Right. I believe we are almost done, unless anyone has another question.
We can still have a voting, sure.
Yes, but yes, I believe it would take 2 minutes to download the Docker image. So yes, so voilà. So if you want, you can try it out and download the Docker image from Error Bars, and then I let you do. I'm just showing you where it is. if no, I don't want to skip verification. It's all about verification. Voilà, ever pass and ever CBOR. And then there is voilà Docker pool. Sorry. Voilà. And then okay, in fact, I think I have it here. And then here I can run ever CDDL. I think on that. Okay, let me just show quickly show how ever CDDL works. I have a test demo, and we are free. Ever CDDL, no CDDL, sorry. TLP. Test. Voilà, so test of CDDL should have shown you, okay, so and now it's generating and proving the correctness of the code that was generated. And then, yes, it will take more than 2 minutes. So,
can you make the output a little bit larger?
in fact, I'm going to show you the, yes, but I'm going to show you the code, the CDDL first, from which I am generating. Allez. SRC, CDDL, allez. The board games, they start at 7? Okay, thank you. But yes, but I'll be done in 2 minutes anyway, so yes. And test.cddl, well, so this is the, voilà, test 1, test 2, voilà, test 3. And then at the end of the day, extracting the C code, voilà. And now I'm going to show you the C code extracted with the larger font. Where is it? Voilà, okay, here. Ah oui, yes. Oh, I don't have it. Okay, then I don't know how to. Sorry?
Cat.
Yeah, but I don't know how to increase the size of it. That's why I wanted to open a new window. But okay, so okay, let me just show you that. Okay, so no, this is the C code. The C code is the serializer. Yes. Ah, yes. I think it's already better. Thank you.
I can see more.
Yes, please. Yes. Yes. So we produce the serializer. That takes a value of the pretty type that is defined in the H file, which is here. This is the type that we produce for type. Where is it? Test 3. It's an alternate. It's an no, sorry. It's an option. Ah yes. No, this is a pair. Okay, so this is a pair, and voilà. Okay, so this is test 3. Well, the tag that we produce for test 3, it's a tag union where the tag is 0 or 1, and the union is test 1 or test 2, and so on. So we generate the types and the parsers and the serializers, and that's right now how the code looks like. Of course, immediate goal for us in the next few days is to improve on the readability of the names produced by the code generator. But at least I wanted to show you at least that the structure of the types from the CDDL descriptions are preserved. I believe that the names can be made shorter, especially by removing all of those prefixes. And well, that's basically where we are right now. And so we have code produced for COSE and for the other protocols that I mentioned earlier in the presentation. Voilà. Maybe I should mention that the types produced by the code generator. I mean, the code generator is the same code generator as the one that is used for Hackerstyle Never Quit. And so it follows the same naming convention. That is, so when we there is room for improvement on that side, and that's pretty much what we aim to do for to make our tool more usable in practice. Thank you.
So when I saw another version of that demo, my comment was that the actual standards variables here in the IETF and elsewhere, of course, will have to wait for compiling the CDDL code each time they make a change in there. So this is maybe a little bit less practical from a development point of view. So something that can interpret the CDDL instead of compiling it into a parser might also be useful.
It may be useful provided we have a proper way of dealing with memory consumption.
Yeah, this would be a development tool. So
Right. Okay.
On big boxes, class 18 devices. I still have the comments from
Thank you. Any other questions? Thank you all, and then I let you play with it more using the Docker image. And if you want to build it and if you have issues, please ask me. Thank you.
Thank you very much.
Thank you.